Let's talk about test exceptions and failures. Now, tests are certainly going to fail, and when fails, somebody should be notified. Now, if the developer is running a test in their sandbox environment, hopefully they're aware that the test has failed. They've got some notification in their IDE, and then they have to decide what to do, right? Do I change the code? Do I check the test to make sure it's still valid? I have to do something. Either one of those could be a valid response, but it depends on what the failure shows and what the requirements are for the application. We certainly do write bad tests at different times, and we may find them as part of the development process. And if that's the case, we have to alter the test. One of the hardest things I think for developers to understand is that testing is building software just like you're building other software, and you may have to change this. Now, if a test fails a build, we have to decide what to do there as well, and that's a little different. The common practice is to email the entire team, and that's so that everybody is aware, and it puts pressure on us to fix this bug immediately. We don't want these bugs to linger. We don't want there to be any problems. And peer pressure is essentially enforcing code quality in this place. Every developer can quickly see who caused the issue, and then we can decide what to do. In continuous integration, the idea is that our code is always ready for release, so that test failures have to be addressed immediately. Either the developer in charge of the code or all the developers or multiple developers need to swarm together around the problem and find a solution very quickly. We don't want our code to linger in that state. Now, if the code cannot be found quickly, or if the solution cannot be found quickly, we want to roll that code back. We want to go back to what known code was and then have the developer fix that. This ensures that our main branch of development code is returned to a releasable state quickly, and that if we have to release other code, we can because we haven't broken the database. When we have a failing test, we don't want any other development or commits to occur and to stack on top of that failing code or that failing test code. If the test can't be passed, we want to probably disable that test rather than let a failure linger. We do this for a couple of reasons. The main one is that the constant negative state conditions developers to start ignoring the issue, and we stop paying attention to it. We then build up technical debt, and we start to not trust our tests because we know we always have failures. We may also miss another failure because we're expecting something to fail. We're kind of not paying attention. The other issue is that because we're working with multiple applications here, it's entirely possible that there is a test that's going to fail for one application, but it's not going to affect others. And we don't want to stop ourselves from releasing that code. So we want to be able to continue forward. Disabling that test allows us to continue forward. Certainly we do need to address the issue at some point in time and remediate it by fixing the code or perhaps acknowledging the requirement is no longer necessary or it's changed and changing the test. But that's up to us. We have to examine each situation here and understand what's going on. The important thing is when we have test exceptions or failures, we have to address those very quickly and either add an exception or fix the code.